I'm Alan. Again, I'm an ML engineer at Voxel 51. That's a great team. I love my job. It's fantastic. I'll just dive right in. As Jimmy was saying, Amazon recently released this new data set. It's huge, serves kind of an underserved community within CV. The robotics and robotic manipulation community, there's not a lot of benchmark data sets. The ones that do exist, either they're kind of limited in scope or number of classes or number of objects, or they're kind of unrealistic. Amazon, as you can imagine, has a huge number of objects, and this data set takes place in the context of an operating Amazon warehouse. So you can imagine it's like very realistic. It's how we get our stuff, or at least those of us who are Amazon customers, and just a huge long tail of products. And so very realistic, brand new and very large data set. It breaks down. There's three kind of pieces of it. It's so big. One is a segmentation data set. One is an identification data set, and one is a defect detection data set, which is what we'll focus on today. And we did blog about it, as Jimmy mentioned, but just before we get into it, I'll just give you a little context here. This is, as we said, this is in the context of an operating Amazon warehouse. So hopefully you guys can see this. This is a robot arm manipulator. That's how we get our stuff in the same day or whatever it is. So the task is the arm comes down, grabs an object out of a tote, and then transfers them one at a time onto a conveyor belt. So that's what's going on. Now, as you imagine, as I said, we'll focus on this defect case. Most of the time that goes well. Every once in a while it doesn't. So that's kind of what we're going to explore today. We did blog about this, so all the details are here. So, there's some background on the data set, but then also a bunch of code as well. So you can follow along if you check out the blog. It sets you up with 51 and loads the data set and so on, and then you can kind of just do everything I'm about to walk you through. So all of that's available here in detail. Cool. All right, so let me just dive in. This is just kind of a brief walkthrough. We'll just have some fun with 51, and I'll show you what this data set looks like. So this is the defect detection data set from our Amazon warehouse. And here, where should we start? On the left, we can start with the annotations. So the annotations here relate to defects primarily, as might make sense. So there are a bunch of classes here listed in the sidebar. The first class is nominal. So that is the technical term for everything went well, right? So everything's okay. But of course, the more interesting ones maybe are some of these defects. So this is what you don't want to happen to your package. So open book jacket. We have some segmentations I can turn off, but here, right? So the robot is coming along. It's trying to pick something up. Oops. Book jacket's opening up. Book is falling out. That's not good. Open box. This is a disaster scenario here. Like, the stuff's falling out of the box. Someone's not going to get their clothes here. This is certainly a defect case. A bunch of these torn bags, crushed boxes, maybe the worst case for any kind of customer, right? If their object gets crushed, they're not going to receive it or it'll be damaged. So the challenge here, right, if you're on the ML team at Amazon, is like, how can we detect this, right? Because if you can detect it, then you can kind of stop it. So we've loaded these annotations in 51 tags. A very common thing they might want to do here is to look at the distribution of these tags. And so I can reset my filter here. So this histogram is built into 51 and will show you all sorts of fields available on your data set. Here, we're showing the tags, which are, again, those defect annotations. So as you can imagine with Amazon, like it almost always goes well. So this first bar is this huge nominal case. So most of the time, everything is fine. I can filter those guys out in the sidebar. I can say nominal. Okay, I don't want to see those. I want to see the crazy stuff. So here, now we can see our class distribution of defects. We have the multi-pick. That's when the robot arm picks up multiple things. Open book jacket, open box. And so for CV, right, this is a standard thing. Like we got to see, like, what does our class distribution look like? Do we have to compensate? Maybe we have some rare cases. So this is something that's really easy to do and opens up right here in the panel. All right, what else is going on? Like something about this data set that's interesting is that it is structured as what we call a group data set. So in the warehouse, there's actually 4 cameras arrayed in a kind of planar configuration. And so they're in 51, we call these slices. So there's camera 1, which is what we're looking at. There is camera 2, which is kind of come a different angle. And it's funny, we got these cameras angled in these kind of crazy ways. There's no right side up, I guess, because for a robot, that doesn't super matter, right, for computer vision. But for us, we kind of have to tilt our heads. This is the 3rd slice. And then for the 4th slice, this is what it looks like. And so what's kind of interesting here, I think, is that, as you might imagine, like the annotations are differ from slice to slice, even for the same object. So this structure is great when you have multiple cameras because you might have a single object, but then many views. If I click into each individual sample, I'm able to see its partners. I can see all of its different views along with the annotations. And I think there's one here that kind of gets interesting here. So here's the case where, one view, well, it's blurry, first of all, but second of all, it doesn't show any defect. And they talk about this, right? This is very crucial, right? Oftentimes you'll need to have multiple cameras, multiple views in order to perform this kind of detection. So that's all like easily visible using our group data set. All right, what else can we do? So this is all kind of like looking at the metadata of our data set. We might be interested in the pixels, right? And so this is something I'll show just briefly about the 51 Brain, which is our package that includes a bunch of like powerful machine learning routines that lets you run machine learning and look at the pixels of your data, right? And here we're going to use it in the context of this defect detection. But of course, there's like countless applications of this, and these are super cool. So here, what we're going to do is run some embeddings. And the idea is, so backing up again, the idea is to try to detect defects. How can we do that? We've looked at metadata, but one thing we might want to do is look at pixels, right? And so you can imagine wanting an appearance model of some kind for your objects and seeing if the appearance can delineate defects. So in 51, it's very easy to isolate crops. So here we'll go from entire images. We don't super care about all that background, right? That's just the warehouse. I can go to a patches view. That's what we call it in 51. That lets you isolate individual objects, individual crops. So now what we're going to do is say, hey, let's generate an appearance model. I'm going to run the OpenAI clip model, and it will generate an embedding vector for each of our objects here. So that essentially is an appearance model, right? And the clip model, we use it a fair amount for examples. It is a general purpose model, but it's also quite powerful. It does pretty well, right? If you're familiar with that, it actually on baseline kind of benchmark cases actually does pretty well. So we'll use this in our embeddings view. So now in our patches view on the left, we've got our objects. There's a one-to-one correspondence with our samples on the right here that are in our embeddings view. You can color by any metadata field you want. So I've colored by essentially the defect. So I've taken our tags and made a single like label class field, basically. So we have our bag defects, we have our book defects, and these are our individual objects. And so we can see in our embedding spot, something probably jumps out right away is that, like, check this out in the lower left, there's this orange cluster, and these are our book defects. And in 51, there's a really easy selection here. We can use our lasso tool, and there's a one-to-one correspondence with our grid. So we can kind of dig in and be like, hey, what's going on over here? Well, if I lasso those guys, in fact, let me turn on my tags again. These are all the book defects. And I kind of go into this on the blog a little bit. You can kind of dig in and, calculate a rough metric or something like that. But, bottom line, there's a ton of signal here in this embedding data, and we're able to find these defects pretty well, at least for the book jacket case. What else can you do? I mean, in the blog, I go into detail, and there's some another case where we look at the bags, which are also quite visible in our embeddings plot. What else can you do? Something that's kind of interesting about this data, right, is that there's this huge sea of nominal cases that don't have any labels. But in fact, our embeddings have already figured out a lot of structure there. If I select this cluster, anytime there's a cluster or embeddings view, right, that probably indicates some kind of interesting grouping. And here I've selected this lobe up here, and of course it is semantically meaningful. It's a bunch of bottles. It's very high fidelity on bottles. Here's another, actually, this is a very small cluster, but this is really funny because down here, these are actually annotation mistakes. The annotator has called these objects, but these are actually not objects. These are part of the Amazon warehouse apparatus. Something funny with 51 Brain, it's very good at finding, non-unique samples, kind of duplicated data, annotation mistakes. If you run brain methods, this comes out really quickly. It's like, hey, that's not an object. That's actually part of the warehouse. So hopefully this just gives you some idea, just a brief, just kind of lightning round on this data set. Like I said, it's available on this blog, so please come check it out. And I should also say, please visit us in our Slack channel. Like, all of us are in there. It's a super fun environment. Don't be shy, like super low key. Like, we're all just kind of like working and learning together. So visit us anytime, and please feel free to send any questions or any points of interest, and be happy to talk with you. Thanks, Jimmy. I'm eager to get off the stage here.
Yeah, but not so fast. You do have one question if you want to check the Q&A widget.
Oh, Okay. Oh, where's the widget?
Look for the toolbar.
Oh, yes. Oh, I'm sorry. Hey, Jimmy, can you help me out? I can't actually. Oh,
Yeah,
I'm sorry.
well,
Is there a particular frame? Oh, I see. Yes. How is a particular frame chosen for training when robot is picking an object? Oh, you mean, yeah, that's a great question. Actually, I don't know how the exact in like which course of the video. So this data set is actually very large. They actually have the entire videos as well. So the data set is very comprehensive, and like what I showed was just one piece of it. How they chose that exact moment in time to take that, that's a great question. Actually, I'm not entirely sure. In terms of training, I mean, you probably want to use as much training data as you can, right? And like, so, you know, once we have these, you know, models, like depending on what you're doing, like you'd obviously want to use as much training data that's interesting as possible. But yeah, in terms of like how that particular frame got selected, I'm actually not sure. But if you check out that data set, they have the entire like video defect section too, where they've got like the entire thing being lifted up and things like that. It's actually really interesting. It turns out it's harder to see some defects in video versus the images and vice versa. So both modalities kind of end up being useful.